If you've ever used a hash set in Java, you've probably wondered, how does it just magically know not to accept duplicates? You can throw the same item at it over and over, and it just works. Well, today we're going to pull back that curtain. In this explainer, you'll see exactly how a hash set works under the hood to make sure every single element is one of a kind.
So let's start with the big question. You've got this collection, and its whole reason for being is to reject duplicates. But how does it know? How can it check a new element against maybe millions of others almost instantly?
The answer in a single word is hashing. This isn't some programming wizardry, it's the core technique that makes sets both unique and incredibly fast. Think of it as a super clever filing system for your data.
To really get how this works, let's look at a classic coding scenario. We'll call it the vanishing duplicate mystery.
Okay, check out this simple piece of code. We make a new hash set. We add the number 10, no problem. Then we add 20, still good. But then we try to add 10 times again. What do you think's gonna happen? An error? A set with 3 items?
And here's the result. The final set just has 10, 20. That second attempt to add 10? It was just silently ignored. The duplicate literally vanished, leaving our collection perfectly unique. This isn't a bug, this is the whole point.
And this brings us right back to our main question, but now it's way more specific. How did the hash set know that the second 10 was a duplicate of the first one? It almost feels like it has some kind of memory, right? And in a way, it does.
So you ready for the big secret? A hash set is actually just a clever wrapper, a disguise for another data structure you probably know, the HashMap. And understanding that is the real key to solving this whole mystery.
Hashing is basically this. You take an object, run it through a special function, and it spits out a number, an integer. We call that a hashCode. It's like the Dewey Decimal System in a library. Instead of walking down every aisle, the code tells you exactly which shelf to go to. It's a high-speed address generator for your data.
See, a hash set isn't one long, simple list. Internally, it's that hash map we mentioned, which is structured kind of like an array of buckets. When you add an element, Java calculates its hash code, and that code points directly to one of these buckets. This is why it's so fast. It doesn't search, it calculates the location.
But hang on a second. What if 2 different objects just happen to generate the exact same hash code? It can happen. We call it a collision. They'd both be sent to the same bucket. So how does Java sort that out? Well, this is where it gets really smart.
It uses a 2-step verification process. First, hashCode is all about speed. It narrows the search down from the entire collection to just one tiny bucket. Then, and only then, does it use the slower equals method. It checks the new element against every other element inside that one bucket. If it finds an identical match, sorry, you're not getting in. The add operation is rejected.
This analogy just nails it. A hashCode is the fast part. It tells you which big filing cabinet drawer to pull open. Equals is the precise part. That's you, reading the labels on the few files inside that one drawer to find the exact one. You need both methods working together for the system to fly.
Now, for things like integers and strings, Java handles all this for you. But, and this is a big but, if you're using your own custom objects, you have to write the rules. It is absolutely critical that you override both equals function and hashCode function. There's a contract. If 2 of your objects are equal, they must return the same hashCode. If you break that contract, the hash set gets confused and you'll end up with those duplicates you were trying to prevent.
So why go through all this trouble? Hash codes, buckets, 2-step checks, what's the point? Well, the payoff is absolutely mind-blowing performance. Let's compare. To see if an array list has something, you have to check every single item, one by one. A million items could mean a million checks. We call this O of n, or linear time. But with a hash set, it jumps directly to the right bucket. The time it takes is basically constant. We call that O of 1. It doesn't matter if you have 100 items or 100 million, the lookup time is pretty much the same.
And just look at what that means in the real world. This benchmark shows a lookup in an array list took over 4,000 nanoseconds. The same search in a hash set, just 9 nanoseconds. That's not just a little faster, it's over 400 times faster. We're talking about a completely different universe of performance.
All right, so let's recap the key takeaways. HashSet uses that internal hash map to do its job. It uses hashCode to find the right storage bucket in a flash. And then it uses equals to confirm if there's a true duplicate. This dream team gives it that incredible O of 1 performance. And remember the most critical part. For your own objects, you must correctly implement both hashcode and equals.
And that brings us to one last thought. We've just demystified the hash set, and we know its secret is that it's using a hash map. So it kind of begs the question, right? How does that hash map itself use this exact same principle to guarantee that all of its keys are unique? Well, that sounds like a great topic for another explainer. Thanks for watching.